Okay, today's lesson, the quadratic formula, lesson objectives. So where did it come from? So we're going to derive the quadratic formula together. It's a bit of algebra, but we will do it together and I hope you can follow it. What does it mean to solve for x? Well, we're going to look at those zeros graphically. And how does a quadratic formula, how can we use it to find the equation of the line of symmetry? That's an interesting one. We'll show you that. We'll also derive a formula for doing that and a formula for finding the vertex. So let's get started. Let a, b, and c be real numbers such that a does not equal 0. The function f of x equals ax squared plus bx plus c is called a quadratic function. And it wouldn't be quadratic if a was equal to 0 because the x squared term would disappear, leaving only a linear equation. So we need a, even if it's just 1, to be there so that x squared is also there. So when solving a quadratic function to find its zeros, we set f of x equal to 0 so that ax squared plus bx plus c equals 0. So we're going to start by solving this for x. So we'll subtract c from both sides, leaving ax squared plus bx equals negative c. Then we'll divide both sides by a. This term will cancel, and we're left with x squared plus b over ax equals negative c over a. And then what we're going to do is we're going to use the process of completing the square. So we're going to take this right here. We're looking for half of BA, which is B over 2A. And we'll see that particular expression quite often. B over 2A. And then we're going to square it, excuse me, and add it to both sides. So B squared over 2A squared being added to both sides of this equal sign. Okay, so here's what it looks like. And what I've done here is I've simply squared 2a squared. So I get 4a squared. And then in the next step, I've rewritten this. See, we complete the square. We do that process to make this into a perfect square trinomial, which means that we can take that b over 2a and do x plus it squared, right? This is how you get that perfect square trinomial. And then over here, what I've done is I've put these over a common denominator. So I took and I multiplied top and bottom by 4a. So the bottom becomes 4a squared and the top becomes negative 4ac. Okay? And then in this next step, I've simply combined the numerators over the one denominator. 4ac plus b squared over 4a squared. Okay? So in this last step here, well, it's not the last step, but I take the square root of both sides. And the square root of something squared, those two operations cancel, leaving x plus b over 2a. And over here, I can take the square root of the denominator, but not the numerator. So I leave a square root in the numerator, and the square root of 4a squared is 2a. So you're seeing it start to shape up now. And don't forget, when we took the square root, we had to do the plus or minus. You know, what's square root of 36? Well, it's plus or minus 6, right? It's not just 6. And I had one question one year, why did you do that on that side but not on that side? Well, it doesn't matter. It doesn't matter. Once I put positive or negative in on either side of the equal sign, well, if they're equal, it's over here too. so it doesn't matter. So the last thing, or the next thing I'm going to do, is I'm going to subtract the b over 2a to get x alone from both sides. And so that's what I did, and this is what I get. And now I'm going to just rewrite that a couple of times. I'm going to put the b over 2a in the front, and since it was minus, it's negative b over 2a, and then plus this. And then I'm going to, since it's a common denominator, I'm going to combine them over the one denominator. And you see, when I'm done doing that, I have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so that is how you derive the quadratic formula. Please be aware, one year the kids came back from Mr. Gould's class crying. This was their final exam to do this. And be aware, one year they came back and this was their test to do this. And so they've had a couple of tests that were simply doing that. So if you need help and Mr. Gould isn't your choice, then feel free to come to me. But now let's just use that. So solve x squared plus 3x minus 10 equals 0. So we take a equals 1, b equals 3, and c equals negative 10. We put it into the quadratic formula. We chew it down a little bit, and we get negative 3 plus or minus 7 over 2. Negative 3 plus 7 is 4, over 2 is 2. Negative 3 minus 7 is negative 10, over 2 is negative 5. And we find that the solution is 2 or negative 5. Great. So now let's see the zeros. Put myself back up in the corner. Let's see our two zeros. So we have negative b plus the square root of b squared minus 4ac over 2a. And we have x squared equals negative b minus the square root of b squared minus 4ac over 2a. And what does that basically mean? Well, here's where that x value occurs. Okay. Well, if you take a look at this, you'll see that there's something, and we can know something in the middle of these two. Like if we wanted to find it on the graph, we could count 6 spaces in between here and go halfway is 3, and we would have our axis of symmetry, our line of symmetry right here at x equals 2. But let's look at something for a moment. So if we look at this, we're going to find that both of these x values are equally spaced on both sides of negative b over 2a. See, this is plus and this is minus. Maybe if I split these into 2 fractions for you, you'll see it easier. So negative b over 2a plus this, negative b over 2a minus this. So since the parabola is centered at that point, negative b over 2a, that x value, then the equation of the line of symmetry will always be x equals negative b over 2a. So here's an example of that. Let's say x squared plus 12x plus 32, find the axis of symmetry. And then we'll find the vertex. So negative b, negative 12, over 2 times 1. Negative 6. There's your x value, your axis of symmetry. X equals negative 6. Now take that negative 6 and put it back in here, and we'll find the point that is the vertex of that parabola. And so negative 6 squared, positive 36, plus 12 times negative 6 is negative 72, negative 72, and positive 36 is negative 36. Negative 36 and 32 is negative 4. So this vertex here would be at the point negative 6 comma negative 4. Okay, so again, now, since we know how to find the x value of that vertex, because it's on the line of symmetry, right? We just take that, that x value, negative b over 2a, and put it into the equation to find the y value. So the vertex is always going to be located at the point negative b over 2a, comma, f of negative b over 2a. Let's look at another example here. So if we had 2x squared plus 8x plus 6, a is 2, b is 8, c is 6, we're going to find the vertex at negative b over 2a, or negative 8 over 2 times 2, which is negative 2. And then to find the y value at that x value, we put negative 2 into there. So f of negative 2. So 2 times negative 2 squared plus 8 times negative 2 plus 6. So 2 times 4, 8. 8 times negative 2, negative 16. 8 minus 16, negative 8, plus 6 gives you negative 2. So that negative 2 should be written here, but for some reason it's invisible. One more example. How would you use this in context? Okay, so someday you're going to take college physics, and they're going to give you this word problem that I have here, and they're going to tell you to write this equation. But lucky you, you're not in college physics. You're in 9th grade math, and you're doing advanced math. So a basketball is thrown from the free throw line a height of 6 feet, from a height of 6 feet. What is the maximum height of the ball if the path is y equals negative 1/9 x squared plus 2x plus 6? Notice, it's thrown from a height of 6 feet. The beginning is at 6 feet. And if you put in a 0 for x for both of these, you would have just plus 6. That's your b. Anyway, that's a little head start on your college physics. So what we're going to do is we're going to just pay attention to the fact that this is a parabola opening down. Read is negative. So it's opening down, and that means that the vertex is going to be where we find a maximum, the maximum height. So, move myself down here onto the floor. Anyway, so A equals negative 1/9 and B equals 2. So negative B over 2A equals 9. And you can do that math and figure that out. And then f of negative B over 2A is f of 9. Put in a 9. 9 squared, 81, times negative 1/9 is negative 9, plus 2 times 9. Negative 9 plus 18 is positive 9, plus 6 is 15, which simply means the vertex is found at the point 9, 15, which means that the height, the maximum height of the ball is 15 feet. Wow, that was a lot of math. Thank you for bearing with me. Thanks again, and we'll see you in class.